Okay, our 5 minutes has elapsed. Who is bailing us out? Kindly mention your name. Hello. Hello.
Hi.
Yes, sir. Hello,
Please,
sir.
are you there? Yes. Are you
Yeah,
there?
we are there, sir. We are there. We
Yes,
are there.
please. So the 5 minutes has elapsed. Somebody should take us through. Okay. Can we discuss together?
Yes, please.
Okay. But take note of such questions. Whether you like it or not, you'll be meeting such question in the end of semester. So please, questions, especially questions that involve numbers. When you come across them, please pay particular attention. Let's go. Now, let x and x plus 2 be equivalent pair of the consecutive odd numbers. Now, I am discussing this one with you. Why is it that I let x be the first odd number and the second number be x plus 2? In case any student or any people or any child asks you, how will you explain this? That the first number is x. Why is it that the second odd number is x plus 2? Why?
Because one property of an odd number is the consecutive addition of consecutive two. When you are
Please
adding
come
two things,
clear. Come clear. Come again,
I
please.
said one property of odd numbers is addition of two.
Okay.
Then if you add
I think I
two,
will
you get
accept.
a second.
I think I will accept it. I will accept it. But let me put it in a mathematical term. Tell the child that odd numbers differ by 2. That is the technical term. Odd numbers
Number.
they differ by 2. Okay. And the same thing goes for even number. Good. Now let's go to the question. 7 times the smaller number subtracted from 9 times the bigger number is 144. So you all believe that x is the smaller number and x plus 2 will be the bigger number. So I will multiply 7 by x, that is 7x, and I subtract from 9 times the bigger number, that's 9 times x plus 2. Expanding and equating, I am getting 9x minus 7x equal to 144 minus 18. X is equal to 63. Remember, x will be my first number because I denoted the first number by x. Then move on to the second number. It's s plus 2. So I am adding the 63 to 2 to get 65. That is my second number. Are you okay with the solution?
Yes, sir.
Yes, sir.
So how
Now,
do we get the plus 2? If x, we know that the first number is x. Where from
okay,
the
my
2
sister,
is
my sister, thank you. What is the first odd number?
number is 1.
Thank you. Second odd number?
Is 3.
Third odd number?
5.
What is the difference between 1 and 3?
2.
The difference is 2.
Difference between 3 and 5?
2.
Is 2.
That's 2.
Difference between 5 and 7?
Is
2.
So every odd number is greater than its preceding odd number by 2.
Okay.
My sister, are you okay?
Yes, sir. Thank you.
Having obtained the two values, the two consecutive odd numbers, this is the time for us to use the polar, the Mason, the model, and other things. Now here we are looking back. Looking back means we want to prove and see whether it fits in the equation. So pick your calculator and help me. The first one is 9 times s plus 2. And my s is 63. So 63 plus 2 will give me 65. Multiply 65 by 9. Please help me. 65 times 9. 65 times 9. What's the answer?
585.
535. Write it somewhere. Minus
585.
535. Write 53 somewhere. So 535.
No, sir. 585.
Okay. 585. Right?
Yes, please.
Good. So 585 minus. Then multiply 7 by 63 for me. 7 by 63. 7 by 63.
441.
Pardon?
441.
441.
So subtract 441 from 585.
144.
That for mathematics. That is mathematics. So we have looked back and saw that now the mathematics is mathematizing. Okay, that's our starter. We move straight to our topic. Today, our first outline or our first subtopic, we are looking at principles guiding teaching of problem solving. Principle guiding teaching of problem solving. We move straight to introduction. I have small introduction here for you. And remind me to send you the slide after lectures. Good. Now, a quick introduction to the principles. True problem solving involves applying a method which is not known offhand to a puzzling situation so as to obtain a reasonable solution. All these things, we have already discussed it. So when it is a problem, we don't know the solution at hand. Now, when they ask you which school of thought underpins the problem solving in mathematics, or which school of thought resonates with the problem solving in mathematics, or which theory agrees with the problem solving in mathematics, we call them constructivist or constructivism theory. Constructivist or constructivism theory. They believe that human beings can construct their own knowledge by using their experience to exploit their own environment. The constructivists, they believe that human beings, they do not learn by passive, but they construct their own knowledge. They develop their own knowledge through experience that they have acquired. The student is an active learner, but not an empty vessel to be filled. Teachers, do not tell yourself that the problem that I am giving to my learners, they do not know anything about it. You are lying. No student is a tabula rasa. No student is an empty-headed. They have something that they have in their mind that they brought from home or that they have experienced it before. So in the field of problem solving, the student must be active, constructing their own knowledge and ideas before they solve their own problem. Do not spoon-feed them. Teacher is the guide on the side. The coach trying to encourage the learner along, and not the sage on the stage imparting knowledge. On the side of problem solving, your duty as the teacher is to guide, is to coach, is to facilitate. When you see that a student is off hand or off the road, it was duty for you to guide him or her to come into the road. Here, student might need a little help. Give it to them, but do not solve the question for the student, or do not give so many clues so they will easily get the answer. Most real-life problems have more than one solutions. You may meet a problem that have more than one solution. Every student in a class can find one approach that they can use to solve the problem that you pose. One question, they may use so many approaches, but they'll get the same answer. Sharing such experience with the rest in class helps in making students develop and extend the range of strategies they have at their disposal.
Absolutely.
Teachers to post worldwide tasks that can give every student the chance of making some progress toward a solution, either on their own or with assistance of others in their group. Encourage group work. The problem that you give to the student to be important, sophisticated problem, the problem that has a solution. There are some teachers, the moment especially, the teacher is late. As soon as you get to class, then you begin exercise. Without solving the exercise and see whether it is feasible. This is the instruction, but they will never find the answer. Then that you realize that there's a problem in the question. No, if what, why, or sophisticated problems. Now, principles guiding teaching of problem solving. Take note, this one could be a full end of semester exams. Principles. Principle number 1, model a useful problem solving method. Problem solving can be challenging and sometimes worrisome. Show students by your example how to be patient and persistent and how to follow a structured method. So here you get learners how to use the appropriate method to solve the problem encountered. Teach within a specific context. Teach within a specific context. Ensure that you teach problem solving and investigation skills in the context in which they will be used. Do not teach in the context whereby the students will never use what you are teaching in their normal life or in their outside world or in their real world. No, teach something that will be useful in their lives. Use real life problems in your explanations, examples, and examinations. Whatever you are teaching, any problem that you want them to solve, at the end of the day, they should be able to know that this problem, I can link it to do this in the market, in my mother's shop, in our various homes. Don't teach problem solving as an independent abstract skill. No. The problem solving shouldn't be an abstract skill. It should be something that is practical, that student can feel it. Help students understand the problem. As soon as you give the problem, the student may have some issues. It's your duty as the teacher, as a facilitator, to help them understand the problem before they can start. Take enough time most of us are afraid mathematics because in our time, teachers will be doing mental 1 + 1, 1 + 2, 1 + 4. Then before you open your mouth, you have received about 5 lashes on your head. We must stop this. When you give them problem solving tasks, we have to take our time. Give them enough time to practice. Give them enough time to read and understand the problem. Give them enough time for them to define their goals individually and as a class. You give them enough time. Do not rush them. If you rush them, they cannot think. Problem solving goes with thinking, making conjectures, making clues, using heuristics. So if you rush them, they will become confused. 5. Ask questions and make suggestions. Ask questions. At a certain point in time, they are confused. You can ask them questions, and based on their response, you can also make suggestions. I suggest that if you go by this way or that way, I think the problem will be easy for you to solve. Or I am suggesting just go to the library, search for this book and that book, and go through, and you'll be bailed out. Link errors to misconceptions. Use miscalculations or mistakes as evidence of not negligence of random guessing. At times, when they make mistakes, they think that this is how it should be. And as a teacher, you know better. You know that it shouldn't be so. So you guide them the reason why their answers shouldn't be so. They shouldn't link it something that it can never be happening, or something that they believe but it does not exist in mathematics. Then I have a question for you. Because of our time, you go through at your own pace. It comes the solution. All these questions that I'm giving to you are past questions. So take your time and go through all these questions. I have taken my time and solved them for you. So you go through one after the other. But when solving it, make sure you either John Polia or John Mason steps. Describe it yourself and go through. So that is that. All these are tasks for you. Good. And I want us to move on to another subtopic for today. Okay, so we are looking at lesson 9, teaching for and about problem solving. We are looking at teaching for problem solving and teaching about problem solving. Remember, they can ask you to write about three differences between teaching for and teaching about problem solving. So by the end of this lesson, you should be able to do so. So you can jot down the question: difference between teaching for and teaching about problem solving. Now we have a preparatory questions here. Have I already given you this task?
Yes, sir.
Thank you.
Yeah.
Thank you. We thank God. We thank God. Then you people are doing it better. Good. Start work. I'll give you 3 minutes. I'll range the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9 in the square such that any row, column, and diagonal have the same sum 15. Please, do you see the question on your screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Should I explain it further or you are okay?
Sir, please explain further.
Good.
Yes,
I
sir.
have given you 9 numbers, 9 boxes, right?
Yes, sir.
Thank you. Every box must contain a number. The numbers shouldn't be repeated. So you need not to get double ones or double twos. Or in other words, 2 needs not to appear twice in the box. At the
Okay.
end of the day, the sum of
I'll
every
go by 6.
row, the sum of every row should give you 15. The sum of every column should give you 15. The sum of every diagonal should give you 15. Start work. Remember, the course is investigation or problem solving. So it's about thinking, using your own ideas. Once you get the answer, then you call me. 3 minutes. Draw the table and fill it. This was the past question. And
I want to ask,
Good. Let's go.
are we solving it right now?
Now, if you are done, once the table is filled and it satisfies the condition, tell us your numbers.
Hello,
Are you feeling?
Okay.
Yes.
Hello.
Hello,
I'm
madam.
done.
Good. Let's
Yes,
go.
sir.
Tell us whether you are filling the numbers row or column. First row of how are you feeling it so that we all go by you.
By row.
By
6,
row. Let's go.
4, 5,
1,
6.
Please
9.
let's pick. Please wait. Let's pick our pens and follow her. She's going by row, so write the numbers.
1,
9,
9, 5.
5.
The
195.
second,
Wait.
yes.
195 is 15. Good. That row has been
Yes.
satisfied.
The second row, 8,
Mhm.
4,
8,
3.
4,
Yes,
3. That is
3.
12. 15.
Yes. The last one, 6, 2, 7.
6, 2, 7. Okay. Add the numbers
Yes.
in the first column for me. What are they?
The first column,
Yes. 1,
1, 8, 6.
187. 1 8 is give us 9.
Yes, plus 6.
Plus 6, 15. Go to the
Yes,
second column.
yes. Okay, 9.
Go to
4.
the second. Go, please.
Yes.
Wait, go back to the first column again. 1 plus
1 plus 8.
1 plus 8, 9.
9,
Yes, plus 6.
Plus
15,
6. Plus 6.
Yes, yes.
15. Okay.
15.
Second column.
9 plus 4 plus 2.
Okay. Last column.
5 plus 3 plus 7.
5 plus. Okay. The leading diagonals.
Yes, diagonal.
Uh-huh.
I have 5 plus 4 plus 6
Take your time. 5 plus 4 plus 6.
plus
The-
6. Yes.
Good. The other diagonal.
The other diagonal is
Uh-huh.
1 plus 5 plus 7.
Okay. 1 plus 5. 1
Yes.
plus 5 is what? 6. 6.
Yes. 5.
So that is 13, right?
Yes.
So the
It's
table is
only
wrong.
that one that's not. Oh,
So only that one. It makes everything 0.
okay.
So
Okay, I'll try again.
come again.
Sir,
Yes, my
please,
man.
mine is ready.
Try again.
Okay,
Sir,
first
please,
row.
mine is ready.
First row.
Sir, first row, I have 2, 9, 4.
Good. 2, 9, 4, 15. Second row.
7, 5, 3.
15. Last row.
6, 1, 8.
First column.
First column is 276.
Last column.
Last column is 438.
Good. Leading diagonal.
Leading diagonal, I have 258.
258. Other diagonal.
456.
Please, let's clap for our brother.
Yes, yes, that will.
So, is there any? Our brother has gotten it correct. 10/10.
Yes.
This one is send the mark graph.
Send him a clap for me. Send him a clap. Me. Okay. Okay. Or you think I don't know send him a clap? I know it. Good. Please, are you clear?
Yes.
Thank you. Let's
Yes,
move on. So please, as you are enjoying with your wife and your husband, come and go to 4x4. I will send them to you. Okay? Good.
Okay.
4x4.
Yes, sir.
You also go through 5x5, and inshallah you will get one. If not 3x3, you get 4x4. If not 4x4, you get 5x5. You take your time. Go through. Mr. Fojo, please. I think it's that this one has already reached surface. Okay. And I have solved it for you. But there are some that I have left for you to complete it. But please solve it before you come for the solution, okay?
Okay.
Just trust yourself. When you are done, the question is in slide 2, and the solution is in slide 3. Okay.
Okay.
I'll send them to you, so don't worry.
Okay,
Now we are looking at teaching for problem solving. Remember, I told you will be asked to differentiate between teaching for problem solving and teaching about problem solving. We are looking at teaching for problem solving. Problem solving skills are general skills that help us. They are general skills that help us tackle the unfamiliar. When somebody has a skill about problem solving, this person can solve unfamiliar questions. When a question is given and you know how to solve it, you know how to go by it offhand, that one is not a problem. Remember, it is an exercise. You remember?
Yes.
Thank you. And I know my student, and I know how best you are reading. I can see from the spread that you are reading the books well. Read it all. Putting people in challenging situations where the route to a solution is not immediately obvious, and giving them experience of that slightly uncomfortable feeling of not knowing is valuable in helping to develop their thinking skills. At this point, this is the problem whereby when a student has chewed the thing, you will not give them in that manner so that they will pour it for you. You wear it a suit and a coat, and those who have chewed the question, they can never get the answer. But they have to put the thing that they have to vomit those that they have chewed and begin to think and think and think and think. So while they are thinking, it's always increasing their thinking abilities. Real mathematics comprises solving real problems. I'm coming. Real mathematics comprises solving real problems. offering students the opportunity to have a go at a problem that may seem totally new and different for them can give them a sense of what it means to do real math. Now, teacher presents the mathematics, students practice the skills, and finally, students solve story problem that require using the skill. So this is what means teaching for problem solving. That is why I have used the red color for you. When we are talking about teaching for problem solving, what does the teacher do? Teacher presents the mathematics, students practice the skills, and finally, students solve the problem that require using the skill. That is teaching for problem solving. The skill or concept by the teacher will be given to the student to practice. Then finally, the student solve the word problem. The skill or the concept that the student will need, the teacher would develop, or we got learner to develop or acquire the concept. Students having acquired the concept, the teacher will guide them for them to practice. After practicing the concept, they use it to solve the word problem. That is teaching for problem solving. Teaching for problem solving. And this one is clear and self-explanatory. Seen as the most helpful approach to learning, teacher walking students through procedure, or teacher showing a step-by-step method for solving a type of a problem. So all these fall under teaching for problem solving. The teacher will take students through the procedure, how to use the procedure, how to solve the step-by-step of a method for solving a type or a particular problem. Approach has not benefited the majority of learners in understanding various concepts in maths. Teaching for problem solving. It is the struggle that leads to learning. So teachers should resist the natural inclination to take away the struggle. The best way to help students is not to help too much. Please, very, 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 very important thing here. The best way to help students is not help too much. I want an explanation here. Somebody should help me. How will you explain this sentence? Yes.
Like you allow the teacher to allow the kids to flow. Try to find
Good.
out answer for themselves.
Thank you.
I mean, we shouldn't spoon feed them.
Spoon feed them. Wow, I like your contribution. Is there any other thing again?
We should make it child-centered so that they come out with their own funding.
Good, because no child is tabula rasa, right?
Yes.
Thank you. But must the teacher help?
Sir, please, the teacher should just direct, should just facilitate and only guide the student, but not to help.
Yes. Okay.
So when you guide, when you facilitate, what are you doing? You are helping. But the help shouldn't be too much.
Yes, a teacher should help, but not too much.
Thank you. Allow them to think. Teacher helping me that you are opening the way for them. As soon as the way is open, you leave them for them to explore on their own. Are you okay? Like, we want to deduce the quadratic formula. Students offhand can never deduce this formula unless a teacher you take them through. So having deduced this formula and you want them to apply it, do not use it to solve problem for them. Allow them to use the formula deduced to solve the problem on their own. That is teaching for problem solving. There are other schools of thought which also against this. They are saying that teaching for problem solving has a lot of negativities, has a lot of disadvantages. That is criticisms against teaching for problem solving. In the exams, if you don't see criticisms, you also see disadvantages. You see this or problems associated with teaching for problem solving, or disadvantages for teaching for problem solving, or criticisms against teaching for problem solving. The first one, the approach requires that every student should possess the needed requisite knowledge to be able to understand what the teacher put forward. It is true. Remember, the teacher will take them through, and having understood, they solve it on their own. So it means that every child must understand. Other than that, that student or child can never solve the task or the problem ahead. And it is a problem. And it is a problem. You will bear with me that at that point, not every child will understand whatever you were teaching at that instant. There are some students, it will take time. So if you go by the teaching for problem solving, that student will always suffer. This mostly doesn't happen. True or false? That at a go, all the students in your class will get your concept so that they can apply. Will it happen like that?
No, sir.
That way.
No. Yes. Good. It makes one believe that there is only one way to solving any particular problem. And you bear with me that it is true. That what a child has given, you want them to use the same approach to solve the task ahead. So they believe that there is only one way, and the way is what the teacher has given them that they should use to solve the problem. That is a criticism. Don't forget these things in the exams. It should be at your fingertips. This in a way misrepresent the field of maths, and also in a way disempower students who may naturally want to outside the box or go outside the box, try a new way of solving the problem. You bear with me that I don't know whether all of us are in a classroom. At times, having deduced your own method and you want students to use it, that is teaching for problem solving. We are deducing the formula. We want them to use it. These students will put your formula aside and they go by their own formula and they will get the same answer. Have you ever witnessed such instances before?
Yes, sir.
Good. But if you want them to go by what we want them to use, it means that those who want to think outside the box, we are limiting them. So this one makes teaching for problem solving a bit problematic. The learner is placed in a passive position, always depending on the teacher to present his or her ideas. True or false?
True.
Yes. So please, in case you get this question in the end of semester, please write whatever is in your heart. Feel free. That without the teacher, the student cannot learn. Without the teacher, they cannot start anything new. Without the teacher, they cannot think on their own. Because the teacher must always start. So if they become passive students, they always take from the teacher, which is not good. Learners do not see themselves as self-determined scholars who have all it takes to solving the problem presented to them. And it is true. The math teacher is not in. Hule, today, no math. It reduces the possibility of a student trying a fresh problem without obvious instruction on how to solve it. Sure, this student must meet a problem. And not being that he's waiting for the teacher. He would have gone outside the box and find a problem or a method to solve it. When the teacher is always there, the possibility there will reduce. Student ends up by saying that, but that is what doing mathematics is. Figuring out an approach to solve the problem at hand. So they will begin to no. Doing mathematics is about finding a formula, getting a formula, solve a problem at hand, and not thinking outside the box. Always, you have to get a formula from somebody before you solve the problem at hand. I have another task for you. At your leisure time, having enjoyed your sunshine meal, you go through for me. Practice all these things. Now we are looking at teaching about problem solving. Teaching about problem solving. We have looked at teaching for, and please let me pause here. I want 2 or 3. I want 2 ladies, 2 big men. Ladies, you are summarizing teaching for problem solving for me. My men, you are to give me 2 criticisms or 2 shortcomings of teaching for problem solving, starting from my ladies. Ladies, are you there? Hello? My ladies.
Yes, sir.
Yes, yes,
Very
we
So,
are.
so please, I want 2 of you to a brief summary, if possible, 2 sentences or 1 sentence. Summarize what problem teaching for problem solving about.
Yeah, sir.
Mm-hmm.
In this case, it's just about guiding the learner to solve a problem, but not teaching the learner. So just give me guide on how to solve it. That's how I understand it.
Are you sure teaching for problem solving, teacher guys? Are you sure?
About it's not
Oh.
teaching about.
Please, please, I have not taught you teaching about this evening. I said summarize what I have already told you. The teaching for problem solving. Summarize this for me.
Okay.
We just finished teaching for.
Okay, so say teaching
Uh-huh.
for problem solving is like a teacher, you trying to help the children to know the practice, the way, the process of solving. Then you leave them to think outside the box to do their own thing. That is how I understand.
Please, thank you. Remember, they don't think outside the box. Teaching for problem solving, the teacher will deduce or will give them the formula. The teacher will give them the pattern. The teacher will give them the way forward for them to use the formula or the theory or the pattern to solve the problem on their own.
Okay.
So always they are depending on the teacher to give them the formula before they will solve the problem. Are you okay?
Yes, please. Thank you.
Sir,
My
please, I
man.
want to ask a question.
Good.
Sir, please, if the teacher is giving the student the formula and the patterns and all that, no, is that not a way of guiding the student?
No, it's not a guiding rather. Rather, the teacher should have guided the student to deduce the formula themselves.
Okay.
Please take it once and for all. You may not hear this until the day that you write the end of semester.
Okay.
At the moment the teacher guides the student to deduce the formula themselves, that one is teaching about problem solving.
Okay, sir.
Okay. You people, you want me to start teaching about problem solving. Meanwhile, the question, my men, shortcomings about teaching for, just give me one, and let's continue.
Oh, I now understand the teaching for very well. Thank you.
Thank you.
Assistant, explain it to us.
So please, for the teaching for problem solving, I think one of the shortcomings is that it makes the student always think there is only one problem to be solved, or there's only one approach or one step.
I like that. I like the second one. There's only one approach or only one method.
One method.
Like that.
Yeah.
Thank you. Thank you. Last one.
Sir, it does not allow learners to think outside the box.
Wonderful. Last one. Don't forget, learners are always passive. They depend on the teacher. Good. Now, let's move on. Teaching about problem solving. Teaching about problem solving means providing a guide or how to solve to students about how to engage in a problem task. Here, whatever you are doing is just a guide. You guide them to find out themselves, and having understood it, they will say, aha, so this is how it is. This is how it works. Okay, I've now seen the reason why the formula for finding perimeter of a rectangle came about. Okay, we want to deduce perimeter of a rectangle. Teacher asked students to take a cutout shape of a rectangle. They have cutout shape of squares of 1 unit. You guide them to fill the cutout shape of the rectangle where there's 1 unit square or the square of 1 unit. They fill it. Having filled it, you guide them to count. You guide them to count the number of square units that occupy the longest side. They write it there. They also count the number of the square units that occupy the shorter side. They also write it down. Then they count all the square units around the rectangular shape. Then ask them to tell you. As so doing, they will tell you that the distance around the rectangle is width plus length plus length. They are students. So how many width do we have? 2. How many length do we have? 2. So let's use algebra. Width plus width, 2W. Length plus length, 2L. So anytime that you give them the formula, they have seen that this is how we deduce the formula. Remember, you just give them a guide and they deduce the formula themselves. That is teaching about problem solving. Although such strategies or guides may be devoid of mathematical content, it is expected that they are generally transferable to a lot of school maths, tasks, and that such thinking are always useful in solving everyday life. So, teaching about problem solving helps students to solve everyday life, because with this one, when they encounter with any problem and the master is not there, they will find a way to deduce their own formula. They will find a way to conjecture a pattern and see whether the pattern works. And solve the problem. Develop the skills of selecting and applying criteria for classification and generalization. Once they are able to deduce their own formula, they will be able to classify problems under their specific places. Communicate effectively using mathematical terms, symbols, and explanation through logical reasoning. When we use teaching about problem solving, students will be able to use mathematical jargons and terms at a certain point. Let's help our students that you will see that the product, instead of saying that 2 times 2 is 4, they will say that the product of two numbers is 4. And the product means that we are multiplying 2 numbers. Quotient means that a number divided by 1, the result is what? The quotient. The sum, we are putting 2 or more numbers together. They will be able to use these terms. Develop ability and willingness to perform investigations using various mathematical ideas and operations. When they are reducing their own problem, they will be able to develop so many ideas about the problem. Students are to receive support from you, the teacher, to acquire skills of 1, mathematical notations to use, or the condition under which a particular mathematical principle or operation works. You are not giving it to them, but you guide them to use appropriate mathematical notation, appropriate mathematical symbols. Yes. So if you are teaching set and the student deduce that, say, in set A, I saw number 2. In set B, I saw number 2. In set C, I saw number 2. So is there any link? Oh, okay. If 2 can be found in all the 3 sets, it means 2 is intersection to all the 3 sets. Or A set, the first set intersection the second set, the third set is 2. In other words, since 2 can be found in all the 3 sets, it becomes an intersection set. And the notation there is what? The intersection symbol. When engaged students in problem-solving activities, it is important to provide some guidance to them as how to engage in problem-solving. That is Van der Waal, 2011, using specific problem strategies such as George Collier's 4 steps. Please, do you remember?
Yes, sir.
What is the first step that John Collier used? I hope my students are not flipping back.
Sir, please,
Good.
understanding the problem.
Understanding the problem, followed by
Devising a plan.
Devising a plan.
Yeah, devising a plan. Yes, sure.
Then the next one.
Carrying out the plan.
You carry out the plan.
The plan.
That is the action time, right?
Yes, please.
Good.
And then look back.
Looking back.
Looking back or look back. Looking back or look back. That is the point that you are out proving your answers, right? You're testing it. Thank you. Oh, may the good Lord be with you. May He give you retentive memory like this for you to get more A's. This code, the A is at your fingertips. So please try. We provide students. Oh, sorry, there is something important here. I have to explain. When we teach students various problem-solving strategies, we are engaging in teaching about problem solving. Teaching about problem solving. When we teach them how to go various problem solving strategies, when we give them more problem solving strategies, like when you encounter this, try this. When you encounter this, just check this. We are talking about teaching about what? Problem solving. We provide students with strategies we believe can help them solve the problem. Remember, it is not a formula that we are giving them. Strategies, the methods, and the methods, it could be the guideline that they are now going to use to deduce their own formula. Understanding the task at hand. Identify and choose an appropriate and efficient solution strategy. Visualizing. Visualizing means that they look at the problem and see whether they understand. Then they look for a pattern. Having understood, they look for a pattern or they look for a formula. Predicting and checking for reasonability. Then they check whether the formula works. They check whether the formula or the pattern is reasonable and it will work. My brother, please, we are getting the feedback. Formulating conjectures and justifying claims. So you prove and see whether your answer is correct. The expectation is that by teaching students these strategies, they will learn to think like a mathematician. Think mathematically, even when they encounter new tasks that they have no immediate solution for it, they will be able to solve it. Now, I also have a task here for you. You go through for me, and another one is also here. You also go through. Remember, do not be tired of my work examples. I know the reason why.
Yes, sir.
So go through. It's tedious, but that is mathematics. So you go through at your pace, time. Good. So that is that for teaching for problem solving and teaching about problem solving. Please, any question? Any question? You make your own notes. Okay.
Sir, please, the tax that is. Sir, please, the tax. Can you re-share it again? We were writing them and doing
please, which tax?
The one that you just said. We were snapping, but you just flip it up.
Okay. Don't you trust me?
We trust you,
Oh, we
sir.
do. Like
We do, sir. We know you will
So I
send it
said,
back.
I said you solve it at your leisure time. So as soon as we are done with
no, we said
lecture,
that. Can you reshare it again? Can you
It
please
will
reshare the
come,
task
don't
again?
worry.
Because
The slide, the
I
you
know
were
slide
our
will be
prepping it
sent
ability
to
first.
to
you.
So
share it. Mhm.
do you know?
It will
Do
The
you know
slide
come.
will
what?
It
be
will
sent.
come.
It will come,
Hello,
don't worry. Man.
hello.
Hi.
Hi.
I have, I have
Hi,
taken it.
sir.
I have taken it up because I want us to progress. When we are done, I will send you
Yes,
the slide. Everything
yes,
there.
sir. Yeah.
Okay.
Oh, okay. Okay, sir.
okay,
Uh-huh.
okay,
Yes,
okay,
Feel free.
okay.
Feel free.
Mhm.
That's why.
Thank you,
That's why you
thank
have
you.
chosen the best. That's why you have chosen the best university in the West Africa. Uh-huh.
Exactly.
We yes, we find out and pass on. And we find out and pass
Sure.
on that the Ghana may be enlightened. Our third class is far better than
Exactly.
somebody's first class.
Exactly.
Mhm.
Sure.
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 Good.
Sir,
Why?
I have a question.
Thank you, Fifi.
Yes, please. My question is that for now we have studied about problem teaching for problem solving and teaching about problem
Good.
solving.
Good.
So I want a clarification here. As a teacher, does it mean
Good.
uh, it is a no-go area for you employing the strategy of teaching for problem solving?
Please, my brother has given us a nice questions, and you are going to write for me to mark. So I want answers from you. In other words, the question was straightforward. Must we accept teaching for problem solving in our daily
Exactly,
teaching?
exactly, sir. Yes.
Uh-huh. Yes, men of God. Uh-huh.
Sir,
Must we
yes, I
accept?
think we,
Yes.
we, we must also accept it.
So my brother, in as much as we are accepting exercise, do you aware that the lowest one among problem solving is exercise? Are you
Mhm.
aware?
Yes.
But exercise helps students to master some computational skills. So in as
Yes.
much as we accept exercise, we also accept teaching for, but it should not be dominated in your teaching.
Mm.
Oh, okay.
Thank
Okay.
you. Thank you. Please, are you convinced
Thank
now?
you so much, sir. Sir,
Welcome.
please, sir, I've understood. Yes,
Thank you.
I'm okay.
Thank
Thank
you.
you so much.
Now let's go. Why is it so? Why it is so? Write down any three numbers less than 10. Write down any three numbers less than 10. Please do it. We are doing this task together. We are doing this task together. Write down any three numbers less than 10. Please don't pick mine. I had 2, 4, and 7. Choose another number. Remember, the number should be less than 10. Three numbers. Do you have them?
Yes,
Yes,
please.
Yes, I
sir.
have
Do
three,
you have
five,
the,
one.
oh, please, madam, do not tell me your numbers, please. Are you okay?
Okay.
Yes,
Yes,
sir.
sir.
Yeah, make all the 6 possible 2-digit numbers using the 3-digit. The 3-digit number that you have chosen. Make 6 2-digit numbers from it for me. Look at mine. Please, I'll give you 2 minutes for you to study mine. I chose 2, 4, and 7. And look at my 2 possible combinations. Can I get 24 for my 3-digit? Look on the screen. Can I get 24?
Yes,
Yes.
please, sir.
Good.
Yes, sir.
Can I get 27?
Yes, please.
Yes.
Yes,
Yes.
sir.
Good. Now, do you know something? The moment you get 24 and 27, take the turning numbers. So the 24 is giving you 42, right?
Yes, sir.
Yes.
Then 27 also giving me 72. Do I have 72 there?
Mm.
Yes, sir.
Good.
Yes,
I
you
can also get 47, right?
Yeah, you have 47.
Once I have 47, the turning number of 47 is what? 74. Are you okay?
Yes.
Then 2 minutes. 2 minutes. Get the sales possible.
Yes.
Start work. 2 minutes. Just get the sales possible 2 digits for me using your own digits. I am waiting for you. 2 minutes.
Okay, so please, we are done.
Thank you. Thank you.
We are done, sir.
So sum them up. Find the sum. Add them. Mine will be 24 plus 7. Add them. Do not tell me the total. Write the total somewhere.
Say I'm done.
Do not tell me your
Okay.
total. Have you done with your total?
Yes, please.
Yes.
Thank you. Add your original 3-digit values. The 3-digit values that you chose. Add them. Me, I have 2 plus 4 plus 7. Add yours. Do not tell me.
8 plus.
Are you done?
Yes, sir.
Yes, please.
Yes.
Now, final step. Divide the sum of the sales 2-digit sales numbers. The sum there divided by the 3-digit. The sum of the 3-digit there.
Sir, I'm done.
What did you get?
Sir, I got
22.
22.
22.
22.
22.
22.
Yeah, man.
I also had 22.
Please do know something. As soon as you get to classroom, use this. The student will clap for you. This smart master is brilliant. Why is this so? Okay. So, at your own letter time, try 3-digit numbers. Okay. Hello. You try 3-digit numbers and see whether you get 2, 2, 2. Try it. Okay. Now we are done with teaching for. We are done with teaching about. We are looking at teaching through problem solving. Teaching through problem solving. Teaching through problem solving. Teaching for and about problem solving approaches indicate that transfer of learning is not straightforward. Teaching for and about problem solving approaches indicate that transfer of learning is not straightforward. Yet the student must pass through so many procedures before he can get the concept. If the goal of teaching math is for students to learn to think mathematically through engaging in problem solving, then problem solving tasks to be at the forefront of our teaching, not at the back end. So if you want them to engage in the problem solving skills, right after the teaching, let them know. We shouldn't finish before we allow them to apply what we have taught them to solve a problem. Teaching through problem solving can be seen as the reverse of teaching for problem solving. Described as upside down from teaching for problem solving, with the problem or task presented at the beginning of a lesson, related knowledge or skills emerging from exploring the problem. So by teaching through the problem, right before even you begin the problem, you begin the class, you give them the task. Please pay attention and listen well. For teaching for, you give them the task. Please, and a big please. I will not go back again. Pay attention. For teaching for, you give them the formula, the pattern for them to use it to solve the problem. But for teaching about, you guide them to deduce the formula, the pattern before they solve it. But for teaching through, you first give them the problem without giving them any pattern, without giving them any formula, without guiding them to deduce any formula. Teaching through, you give them the problem. Then they think about this problem before they come out with their own formula or with their own part. Hallelujah.
Amen.
I hope I am clear.
Amen.
For, for teaching for, you give them the formula, the pattern, for them to use it to solve the problem. For teaching about, you guide them to deduce the formula or the pattern and use it to solve the problem. For teaching through, you first give them the problem. They read the problem, they understand before they deduce their own pattern and formula. Hope it's clear.
Yes.
Yes, sir.
Thank you. Wonderful. The goal is for students to learn precisely the mathematical idea that the curriculum calls for them to learn. The lesson would begin with the teacher setting up the context and introducing the problem. I hope that this one, the A, has made my point clear. The lesson would begin with the teacher setting up the context and introducing the whole problem. Here, the teacher does not introduce a formula or a pattern or a guideline to deduce the formula, but he or she rather introduces the problem. So the moment you would see this, when the teacher starts a lesson by introducing the problem, that teacher is teaching through the problem solving. Objective, grab it once and for all. Students then work on the problem for about 10 minutes while the teacher monitors their progress and notes which students are using which approaches. And B, make it clearer. Are you there? The students,
Yes.
they do what?
Yes, please.
They work on the problem for about what? 10
minutes.
That is the least. You give them the problem, bam, then you leave them. Just go around, just monitor them. That you could see different formulas, different approaches that they are using, that you the teacher might not come across before. Beloved, 21st century teachers, let us also learn from our case. You bear with me that in a class, you may meet a student, that the student is brilliant than you. Will you accept this?
Yes, sir.
It is very difficult for a black teacher to accept this, right?
Hardly.
And I am basing on assumption that if you look at the child at that age, what he is doing when you were at that age, you weren't able to do that work. True or false?
Exactly. Exactly.
Sure. So when this child gets, when this child gets to your age, he will build a ship. So
These days, the children we have there, they are sharp too.
Thank you, my boss. Thank you that you are testifying to this fact. Thank you. The other day I was teaching. I can't remember when I was teaching this topic. Matrices. And I was teaching multiplication of 2 by 2 matrices. I taught them the first step. Then one of the students raised up his hand and said, but you taught us how to multiply a matrix by a vector. And I think if you go by that one, you'll still get us. Quickly, I gave him the marker. Lo and behold, within 2 seconds, the solution is there. Bam. And the student, shabble. And they asked me, say, if you do this in the exam, will you be marked correct? And I say yes. Don't be shy and so what? If the child has come out with a formula that is clearer and faster than yours, you have to discard it. If you do that, you are not a 21st century teacher. Allow them. They are thinking. They are the thinking stage. And remember, at that stage, they don't pay top money. They don't pay TNT. They don't buy uniform. So they use
no
their
water
mind.
bill.
No water bill. You might be in a class whereby your wife is calling you, your child is sick. Half of the mind is gone. Which ideas are incorrect and why? Teaching through problem solving, they can question their own solution. Why is it that this idea is correct? Why is it that this one is not correct? And why? Which ideas are correct? Which one are similar to each other? which one are more efficient and more elegant? You will meet a student and they will ask you, say, I have 3 methods. They are all worked, but I think the first one is faster. And those of you, do I have some of the elective math students here?
Yes.
Yes, you bear with me that. Good. You bear with me that simultaneous equation, we can use elimination method. We can use substitution method. We can use graphical method. This one is for core mathematics, right?
Yes.
Yes, sir.
The same spontaneous equation. We can use Cramer's rule. Do you remember?
Yes, we can use Cramer's rule. Yes.
We can also use inverse method.
So and that one is even faster than using the elimination.
Good. Yes, the inverse method is the fastest. Something happened in my school. You know, I am the HOD in my school, and this student gave a question about statistics, and the student at the end of the day, this student had must use simultaneous equation to solve this stat problem, and a science student quickly used the inverse method to solve it. A teacher having taught core math for so many years. A teacher having taught core math for so many years without elective math, mark these students wrong. I was in my office. I was in my office when this chat came. Say, when you were teaching, you taught us that we can use this one and they will mark out correct. Have you seen that? I had the same answer with my colleagues. Say has marked me wrong. And I'm to put it down and leave. I called the master and asked that in maths, the only thing that we are interested in is the method. As soon as the method is correct, the answer is correct. So teacher, sit down and go through. Find a nice story.
Hello.
Hello. You find a nice story, then you tell your kid that, please, the answer is correct and I have accepted it. I'm going to add up to your marks. So teachers, whenever you come across any new method, do not hesitate to conclude that the answer is wrong. Do not rush. Do not rush. Okay?
Yeah.
Now, in the 21st century, so many methods are emerging. So many methods. So many methods. So we are all learning. Everybody is learning. Remember, one of the renowned educationalists said that education begins from the day we emerge from our mother's womb to the day we enter into our tomb. True or false? So until you die, you are still learning. Even if when you have 1 minute to die, you still learn. Good. As well as placing focus and attention on ideas and sense making rather than on teacher direction and rules. Put this one at the back of your medulla oblongata. That teaching through problem solving. Hello.
Hello, sir. We can see your screen.
Master, please share your screen.
The screen is loading, sir.
You or me?
Sir, please, I can hardly hear you.
Okay. The screen is
hey,
please, maybe it might be your network because some of us are getting it.
Yes, and
I would advise that those who cannot get the screen should maybe go off and still come back again.
Okay, yeah, because network might be your network, yes. Okay, and don't worry. And don't worry, when I'm done, I will send you the slides.
So okay? What is your problem? Keep quiet and listen. Oh,
okay, sir.
Sir, please, I can't hear you.
Okay, so but I am shouting. Can't you hear my voice?
We can hear you.
It's very thin. I can't hear.
Madam,
you go off and come back.
It is clear. We can hear. It is clear.
Thank you. Okay. Is it that you go off and rejoin, and that would be better for you? Okay. Good. So I was saying that teaching through problem solving, our attention is on ideas and sense making. Please, Write this one down. But you can still get it in my slides. For teaching through problem solving, our attention is on ideas and sense making rather than on teacher directions and rules. The moment teacher
Sir, please, there's a feedback. Someone's mic is on. There's a feedback.
Yes, I can even hear it. Please do us a favor. Okay. So what I was saying is that for teaching through problem solving, the attention is on sense, ideas and sense making. If our attention is on ideas and sense making, rather than on teacher directions and rules, the moment the teacher directs, the moment teacher gives rules, then we are talking about teaching for and teaching about. But when our attention or when our focus is on ideas and sense making by students themselves, that one is what? Teaching what? Through problem solving. And remember, teaching through problem solving, we begin by introducing the problem for students to go through and deduce their own pattern and formulas to solve it. Also means allowing students to wonder why things are. Yes, once you begin with the problem, they will begin to wonder why this problem. Then they to inquire. To inquire means to find out, to investigate. To inquire means to find out, to investigate the reason why or what they want, to search for solutions. And in searching for solutions means that the answer is not off-head. They cannot look for the question and give you the answer. They have to explore and to resolve incongruities. Incongruities mean that whatever they see is perplexing or confusing them, they find a way to resolve them. In teaching through problem solving, our style of teaching should be exact opposite of teaching by telling. Teaching by what? Telling. Teaching by telling simple. Teaching by telling simple means that one of my men said it right from the onset. Teaching by telling me that we are spoon feeding them. And when we are teaching through problem solving, we don't need to spoon feed the student. 2 + 2 is this. When you go to the take this, no. Do not do the explaining. So this in the quiz, they can ask you, teaching through problem solving. Teachers can do all the following except. So when you see any of these, is the answer. Do not do the explaining. You are not supposed to explain the problem to the learners. Develop the belief that students are capable of doing math and make sense of math. And do not teach by telling them. Teaching through problem solving. 2 ways. 3-part lesson format. 3-part lesson format. So teaching through problem solving has 3-part lesson format. Please note it down. Teaching through problem solving has 3-part lesson format. These are before, during, and after. The 3-part lesson format of teaching through problem solving are before, during, and after. These are the 3-part lesson format. Before they start, what should they do? During, what should they do? And after. Before they start, here, first you give them the problem. Having given them the problem, then they think through, they find out the formula, the conjunctions, the patterns. That is the during. Then the after. Having obtained their solution, they have to check back and see whether the solution fits to the formula that they deduce. Then think per share strategy. I would want to pause here and want somebody to take us through the meaning of think per share strategy. Teaching through problem solving, we want learners to use think per share strategy. What is the meaning of think per share strategy? Yes.
So, hello, sir.
Yeah.
Please, that think per share strategy is done by the students themselves. They talk, they discuss it among themselves, and then they come out with their views concerning about the question that is being imposed.
Okay. I'll accept it. Next person.
So here, they give the problem to the learners. They think about the problem, how they will solve the problem, then they share it with a friend.
Okay, wonderful. Next person.
Hello,
Okay.
sir.
Yeah, boss.
I think pair sharing strategy is a collaborative learning technique, and that
Okay.
it encourage learners to think critically, share ideas, and learn from one another.
Thank you. Okay. In a summary, think per share. They work in smaller groups. Okay. They work in smaller groups. Having done, they share what they have obtained in their group with the other group. And by the time they realize, they might have shared it in the larger class. That is think per share. Then we also have think per ink share. Have you heard it before? Think per ink share.
Yes,
Yes,
sir.
sir.
Okay, then explain that one for me. Think per ink share.
So with that one, to my understanding, when a problem is given, they think about it in groups. Then the ink one talks about writing their method or their solution about the problem. Then they share it to the larger class.
Come again.
I said when a problem is given, they think about the problem as to their strategies and the solution to solve the problem. Then after that, the ink deals with writing the strategies and the way to go about the problem. Then later they share it to the friends and the larger class.
Okay. There is something that it is missing, and who is helping me? My brother, did you make mention of anything like writing?
Yeah.
Are you sure? Then come again.
Yes, he did.
Okay. All what I wanted to hear is the word write. Because of ink, this time around they are going to write before they share. Okay.
Yes, sir.
Okay. Some of you
Okay,
can
sir.
see my screen, right? Some of you can see my screen, right?
Yes, sir.
Yes, you
Yes,
can
sir.
see.
You know,
Yes, sir.
you know UCC. We will not ask you a question without asking you to add illustrations, right? Yes. So this is the typical example of teaching through problem solving. Remember, it starts with a problem and start lesson on simultaneous equation with the problem. So I am starting this one with you. Somebody should read for us.
Okay. So, sir,
Okay. A
I'm not.
farmer has only goats and hens in his farm. On a particular day, he sold 12 animals. It's bracket goats and hens. And the total number of their legs was 32. How many goats and how many hens did he sell that day?
Thank you. So this is a typical example. If I begin the class like this, I am using teaching through. Are you okay?
Yes, sir.
Help me to form two simultaneous equations.
A
Yes.
farmer has only two. A farmer only has. Was it a farmer has only goats and
The
hens?
first equation will give us
Goats and hens. On a particular day, he sold 12 animals. 20 goats, no? G plus H is equal to 12. Then how was it? And the total number of let's see, and the total number of their legs was 32. The 32, no, hence, no, goes there 4. So 4G plus hence we get to HG is equal to H 2H is equal to 32.
Okay. So do you know what? I am giving that one to you as a task. Feel free. Tomorrow early in the morning or tomorrow in the evening, you go through. When you are done, please let me get the solutions. And you know where to channel your solutions to, right?
Yes, sir.
Yes, sir.
Thank you. Teaching through problem solving basically means students learn math through inquiry. Students learn math through what? Inquiry. They learn math through finding out, through investigation, through searching. That is teaching through problem solving. Students learn math through what? Inquiry. They learn math through investigation, through finding things out, through searching. Students are allowed to exploit the real context, exploit the problems, situations, and models. And from those explorations, they learn math. Teaching through problem solving also acknowledges what we know about what it means to learn and do math. Our knowing is always changing, incomplete, situated in a context, and interconnected. What we learn through problem solving and inquiry becomes part of our expanding and evolving network of ideas, a network without endpoint. Once you deduce your own formula and it works, you will never and ever forget it. You always move with it and you become glad. You move with chest out that I solved it with my own problem. The problem has become mine. Effective mathematics is understanding what learner knows, what learner needs to know, and challenging and supporting the learner to learn it well. Teaching through problem solving moves the attention from learning about math through the teacher's presentation of a new ideas to engaging with math to ascertain key mathematical concepts. So we move from the teachers giving the new idea to the learners. Rather, the students find those new ideas themselves. Teaching through problem enables students to ask appropriate questions that will lead them to unveiling the truth for themselves and designing a solution. They ask questions that will help them to solve the problem, their own problem. I think if you have any question, please feel free to ask me. We are moving on to our last slide. Our last slide. Questions under teaching through. If there's no question, we are moving on to the last one. The role of the teacher. Role of the teacher. What role does the teacher play when it comes to problem solving? One, the role of the teacher in teaching through problem solving. One, modeling a useful problem solving method. Teacher to show students by their own example how to be patient and present how to follow. Hello?
Sir.
Hello, boss.
My hand is Apple.
Oh, okay.
Yeah, please, sir. In the exam, the scenario, are you going to solve the problem?
Okay. Nice questions, though. There is a saying that he who pays the piper must dance to the tune. You understand my proverb?
No,
once you give us an illustration, you solve it for us.
Oh, okay.
Okay, thank you. A nice question, though. Nice question, though. But when he says buttress your point with an illustration, you can also decide not to solve it. And we will mark it for you. But there's a saying that if it must be done, it must be done
well.
Thank you. Well. Thank you. Right. Teacher to show students by their own example how to be patient. So you guide them that when they encounter any problem, they should be patient and those didn't rush things. Give them ample time. Another rule, teaching within a specific context. Please, when you want them to learn word cloud equation, it should be simultaneous equation. Do not jumble things up. Word problem on this, word problem on this on the same day. No, it should be different contexts. Use real life problems in explanation, examples, and tests. What we are saying is that you want them to use word problems in simultaneous equation. That word problem should be the one that they can see it in the real world. Do not limit to the classroom that I mean I have 12 books. No. Look at my example. I use hen and goat. Real life. You will not see live goats in the classroom. But when they go home, they will, on their way home, they will meet hen, they will meet goats. Okay, today Sir made mention about goat. So in mass, we can also use goat in mass. Okay. Then they begin to like the mass. Do not teach problem solving as an independent abstract skill. I've already made mention this. So helping students understand the problem. If the student at a certain point they cannot make progress, help them to understand the problem. Remember, the task that I just gave you, I don't want you to struggle and struggle and struggle. I gave you the title. That the title is what? Simultaneous what? Equation, right? So when you see your students suffering,
Yes, sir.
tell them that this one, the whole of this problem is about finding percentage error. The whole of this problem, we are looking at rates, and they will get that concept. Think, taking enough time, teachers, even if you forget anything, as you grow in teaching problem solving, do not forget this. Taking enough time is one of your rules, one of your responsibility as a teacher when teaching problem solving. Give them enough time. The moment they couldn't finish, then it leads to mathematical anxiety. There are some of you bear with that in our school time. Not that we don't know, but the time given to us was too limited. If for somebody, mind it, but mass, we also mean the accuracy. If I couldn't finish, that so time. Yes, sir. The answer is yes, because it has been said by the scholars, the chief examiners. Chief examiners use 10 questions. Assume that 2 hours 30 minutes for our students. Good. Ask the question, suggest.
I think his network is not working now.
Okay, I thought it's only me, Carl.
Yeah.
Not maybe your network is not good.
I thought my bundle is finished.
The
So
network has just come on.
you
He
reach
has
out.
gone
It is
off
not
off
functioning
now.
here.
Oh, okay, maybe his phone is off.
So let's
I'm
wait
sure
a
it's the
moment.
network.
Maybe.
If anyone has his number, please call him and let's find out if we can reach him.
All right, I will do that.
Okay.
whatever.
So, Nyameche, please, are you back?
Hello. Yes, please.
Yeah, I'm
Hey,
here.
Nyameche gave
His
a
number is
comment
not going through.
that his line is not going through. So, guys, what do we do now?
Could it be that his phone is off?
Most time, we couldn't get there. We need to more time.
Yeah, that could be true.
To give us,
Could
please let me try for
be
the
true.
last time.
Okay.
Please, will Pastor come back again?
I don't think so.
For that one,
Please,
no one can
he's
tell.
calling
Because it's
him for
more
the
than
last
maybe
time.
20 or
It's
15
almost.
minutes now.
He's calling him for the last time.
And he has already told us that he's
Okay,
going to
then.
share the
Okay,
slide.
fine. Yes. So let's find out what our brother said. Our brother says he's checking on him again, so we are waiting for him.
No wahala.
Online for you, mathematics online.
This one there is real
I'm
headache.
telling you.
I just joined. Hello.
Yeah, Namiche, we are waiting for the results. How far?
So his line is not going through, so I think we should call it a day.
I'm
Or
sure his
maybe the
phone
laptop
went
or the phone
off.
is off.
Because how the thing happened,
Yes.
it's not about network. Maybe the phone went
And
off.
moreover, I think if there is any other thing you want to share with us, the platform is always available. He will do that. So
I think so.
I think that we can call it a day.
So anytime he comes on, he will alert us.
Okay.
Good
Yes,
night to
yes,
you all.
yes.
All right.
Master has
Goodbye.
sent message through the group, so
Okay.
I think we
Good
should go
night.
to the group and see. Good night.
Okay. He said the
That
session has come
yes,
to an
that
end.
session has come to an end. Yes, so
Yeah, okay, then.
good
Well
night to
confirmed.
everyone.
Good
Yeah.
night.
Okay.
Mm-hmm.
Good night.
Bye-bye.
Bye.
Amen. Talk, eh?
Lydia.
Anytime.
Okay, good night.
Anytime
Lydia,
you
Good
go and
come
do
here.
night.
the do's.
Good
I
night,
swear to
Doctor. We
God,
are
they
talking.
do. What to do?
Go and do the do's.
Me,
Go and do the
what to do? There is nothing to do.
Oh, Madam Lydia, go and try. Go and try one this night. I'm giving you the permit.
Okay, I hear.
Yes. Okay, then good night.
You're right.
Good
Bye
night.
bye.
Some will never talk. They will only be quiet and listen. Masaya Munkasa.
Next time you back at
Mmaa no deɛ yɛpɛ kasa ntie deɛ yɛbɛkasa na mmarima no deɛ
the Jama Masa Moncasa.
saa ɔho yɛate.
Yo.
Okay. I hope sɛ yɛnhyia biem na yɛakɔyɛ quiz o.
I was saying she wana.
Ɛyɛ asɛm o.
We are very fine.
Yeah, better try. Brothers, mama Canada, my the phone out to baby Anna. Hey, baby, do my phone out to.
You any kwado?
Pacho you, I had the year why.
You also the you.
I am a mutu die.
And I come back at your baby sheda.
Yeah.
I can make an answer. We be so man. Sana wona work.
So the mother baby I fast to who fast
Fast and hurry up.
I make capture fast and hurry up.
Okay. I mean, I don't mind.
And near that for through.
Alright.
I talk.
But you say,
Me catch ya say on kasa.
yeah.
Eh, I'm
Hello,
meeting in my
hello, senior. Yeah.
without talking. Elisha, you're back.
Madam Lydia Sekasa.
Wahoo, Monkasa.
I saw Bobo Beans. Bobo Beans. Oh, was I do not see beans in him.
Encourage your base now.
Okay.
Mm-hmm. Okay, Monkasa, dear near Mama by you. I'm also living. When I pin him, is a Wajame Hokon.
When will be a free and go out in a high. When do